Video is to show the different operations that you can do with polynomials. We're going to focus on adding, subtracting, and multiplying. So the first thing that we're going to start with is adding or subtracting. So for our vocabulary, you may see the terms monomial, which means there's just one term. Binomial, think bicycle, that means there's two terms. And then trinomial, think tricycle, there's three wheels in a tricycle, so trinomial has three terms. Those are primarily the polynomials that we're going to focus on. So for adding polynomials, I'm going to skip to example 3. So for example 3, you can see I have negative 3x squared plus 4x minus 3, and then it's being added to another polynomial. Basically what you're doing is combining like terms. So how I like to do these kind of problems is if you set your polynomials up vertically, it's a little bit easier to see what the like terms are. So my first polynomial I did in pink, my second polynomial I'm going to do in purple. But I don't have an x squared, so that's going to be 0x squared. Okay, so if you don't ever have a term, then just put a 0 there. And then I have negative 8x and I have 9. Okay, the last thing that I'm going to do to get my final answer is there's a plus sign in between them. So I'm going to do plus, plus, plus. So negative 3 plus 0 is negative 3x squared. 4x plus negative 8x is negative 4x. And then 3 plus 9, sorry, that's a negative 3. Negative 3 plus 9 is 6. Okay, so my final answer would be negative 3x squared minus 4x plus 6. Okay, and then for example 4, I would just do the same thing. So I'm going to put the first polynomial in my first column, 5x squared, 2x, and 3. And then I would put the second polynomial in my second column, x squared, negative x, and 1. Make sure you keep your signs with each number. These are really ones, okay? And then it has a plus sign in between the polynomial. So we're going to do plus, plus, plus. So 5 plus 1 is 6x squared, 2 plus negative 1 is 1x, and 3 plus 1 is 4. So my final answer would be 6x squared plus 1x plus 4. I'll go ahead and show you one subtraction problem too. For subtraction, you're basically going to do the same thing. We can go ahead and set our like terms up vertically. I mean, really, you're just combining like terms, so you don't have to do this vertically if you don't want to. I'm going to put a 0x squared again because there is no x squared in the second polynomial, and then negative 8x in 9. Okay, I just think it's easier to see what your like terms are when you do set it up vertically. And then you're going to subtract, subtract, subtract. So negative 3 minus 0 would be negative 3x squared. 4 minus negative 8. When you have minus and negative, that's really like a positive, a plus. So 4 plus 8 would be 12x. And then negative 3 minus 9 would be negative 12. So your final answer would be negative 3x squared plus 12x minus 12. Okay, you would do the same thing for the next one. You're probably getting the point by now, though. So we're going to go ahead and move on to multiplying polynomials. So the first one that I'll cover quickly is when you have a monomial times a polynomial. When you have a monomial times a polynomial, it's just like the distributive property. Okay, so if I showed you this first one with the x method or the box method, you would just put the 2x out front because the 2x is your monomial, and then your other polynomial would be the terms that we would put on top of these boxes. Okay, and again, it's really just like you're distributing. So 2x times 3x squared, 2 times 3 is 6. But the important thing with multiplying is that you do have to change your exponent. So think about the exponent rules. When I have x to the first and x squared, 1 plus 2 would be x to the third. Okay, then 2x to the first times 2x to the first. 2 times 2 is 4, but if I add up those exponents, it would be x squared. And then 2x times 4 is just 8x because the 4 does not have the x, so I don't increase the exponent. I just keep the x there. Okay, we'll get into that a little bit more when we do a binomial times a binomial. So for a binomial times a binomial, I'm going to show you using the box method again. I'm going to put this first polynomial out front. So it's a 2x and a positive 3. And then my second polynomial I'm going to put on the top of the box, x and 5. So 2x times 1x would be 2x to the second, because x to the first and x to the first would make x squared. 2x times 5 would be 10x. Then 3 times x would be 3x. And then 3 times 5 would be 15. Okay, so really just what you're doing is in each individual box, you're multiplying the two things that are on the outside. Okay, so for my final answer, I need to combine any like terms. So I don't see any other x squared, so I'm just going to bring the 2x squared down. I do see multiple x's, so 3x plus 10x would just be 13x. Notice I don't increase the exponent when I'm adding them. Okay, and then there's no other number besides that positive 15, so I bring down the plus 15. That would be your final answer. Okay, I'm going to show you one more for a binomial times a binomial. So I'm going to put this out front, 4x and negative 3. And then I'm going to put this guy on the top, 3x and negative 2. And then we're just going to multiply. So 4x times 3x would be 12x squared. Okay, because x to the first and x to the first is x to the second. 4x times negative 2 is negative 8x. Negative 3 times 3x is negative 9x. And negative 3 times negative 2 is positive 6. So to get your final answer, there's no other x squared, so I bring my 12x squared down. But we do have negative 9x and negative 8x, so that would be negative 17x. And then there's no other numbers, so we bring down our plus 6. So that's my final answer, 12x squared minus 17x plus 6. Some of you also may have learned this as the FOIL method. So if you had one of these special cases, which you will have one of these special cases on your quiz or your check for understanding, if you have a binomial squared, you cannot just distribute the exponent. If you have a binomial squared, you need to write the binomial twice. So it'd be 5x minus 2 times 5x minus 2, and then I would go ahead and do my box method. Okay, so if I set up my box, I'm going to make a 2 by 2 box because there's 2 terms in the first one and 2 terms in the second one. We got 5x and negative 2, and then 5x and negative 2. Okay, so 5x times 5x would be 25x squared because 1 plus 1 is x to the second. 5x times negative 2 is negative 10x. 5x times negative 2 is negative 10x, and then negative 2 times negative 2 is positive 4. So my final answer would be 25x squared because I don't have any other x squareds. And then negative 10x and negative 10x is negative 20x. And then we bring down our positive 4. Okay, so that's my final answer. You could also do this using the FOIL method. So if you've ever heard of the FOIL method, FOIL stands for first, outside, inside, last. Okay, it's really just showing you that this is distributive property whether you're using the box or not. So if I use the FOIL method or distributive property instead of the box, 5x times 5x is just 25x squared. Okay, that's my first terms. Then if I do my outer terms would be 5x and negative 2. 5 times negative 2 would be negative 10x. Okay, then my inner terms, negative 2 times 5x is negative 10x. And then I also can't forget to do my last terms. Negative 2 times negative 2 is positive 4. So if you combine your center terms, you would still get 25x squared minus 20x plus 4. So either way, whether you use the box or just distributive property, you get the same answer. Okay, and then this can be applied to any scenario. When you have a binomial times any polynomial, you could just set up your box to figure out your answer. So I'm going to show you the box for a binomial times a trinomial. So we have two terms here, so x and 4. And we have three terms here, so x squared, 6x, and 8. Now I'm just going to fill out my box. So I have 1x to the first times 1x squared. 1 times 1 is 1, but it would be x to the third. Then 1x times 6x would be 6x to the second, because 1 plus 1 is 2. Then 1x times 8 would just be 8x. Okay, now I'm going to go ahead and do the bottom row. So 4 times x squared would be 4x squared. 4 times 6x would be 24x. And then 4 times 8 would be 32. Okay, so to get my final answer, I'm just going to look for any like terms. So there's no other x to the thirds. Okay, so I just bring that down. 4x squared and 6x squared. 4 plus 6 would be 10x squared. Okay, then 24x plus 8x would be 32x. And then there's no other number, so I bring down my plus 32. Okay, that would be your final answer. So the box method works for any scenario. And then the last thing that I'm going to show you is when you have an area or a perimeter problem. So for perimeter problems, you just add up all the sides. Okay, so perimeter means add. So if I look at all my x's in this triangle, 3x, 4x, and 5x. 3 plus 5 is 8, plus 4 is 12, so it would be 12x. And then if I add up all my numbers, 8, negative 1, and 2. 8 plus negative 1 is 7, plus 2 is 9. So my final answer for the perimeter would be 12x plus 9. So since we're adding for the perimeter, we're not changing any exponents. Okay, I'll show you one more perimeter problem. For the last perimeter problem, it's a rectangle. We need to make sure that we fill out all sides of the rectangle. So if the left is 2x minus 3, the right is 2x minus 3. And if the bottom is 4x minus 7, then the top is 4x minus 7. Okay, then we just combine our like terms. So 4x, 2x, 4x, 2x. 4 plus 2 is 6, plus 4 is 10. Plus 2 is 12. So this would be 12x. And then we're going to add up all our numbers. Negative 7, negative 3, negative 7, negative 3. If you add up all those numbers, negative 7 plus negative 3 is negative 10. Plus negative 7 is negative 17. Plus negative 3 is negative 20. You'd get 12x minus 20 as your perimeter. And then the last problem that we're going to do is area. So if we were to find area, area is when we multiply. So for this one, we would just do length times width. So we do 4x plus 8 times 2x plus 3, and we just set up our box method. I'm not going to actually solve that one because I'm going to do that later on. Okay, if we were to solve one of the trickier problems, like this one right here, this is going to be the last question on your check for understanding. Okay, if we wanted to find the area of the shaded region, this would be our game plan. We're going to find the area of the big rectangle, and we're going to subtract it from the area of the small rectangle. So for the area of the big rectangle, we're going to use these two sides, 11x minus 6 and 7x plus 4. And to multiply those, I'm going to do my box. So we got 11x, negative 6, 7x, and 4. 11 times 7 is 77. That would be x to the second. 11x times 4 would be 44x. 7x times negative 6 would be negative 42x. And then negative 6 times 4 would be negative 24. So my final answer, when I combine like terms, there's no other x squareds. 44 and negative 42x would be positive 2x, and then I bring down my minus 24. Okay, and then last thing I'm going to do is I'm going to find the area of the small rectangle. So I take the two sides from the small rectangle and multiply them together. So I'm going to do 8x plus 3 and 5x minus 2. And I'm going to do my box for that. So I got 8x, 3, 5x, negative 2. So 8x times 5x is 40x squared. 8x times negative 2 is negative 16x. 3 times 5x is 15x. And then 3 times negative 2 is negative 6. So my final answer would be 40x squared. If I combine 15x and negative 16x, that would be negative 1x. And then negative 6. So I found the area of the big rectangle and the area of the small rectangle. So my last step is just to subtract my two answers. So to subtract my two answers, I'm going to set them up in a column, just like I did for the adding and subtracting notes. Okay, so there's my first polynomial, there's my second polynomial, and then we're going to minus, minus, minus. So 77x squared minus 40x squared would be 37x squared. 2x minus negative 1x minus a negative is like a positive. That would be 3x. And then negative 24 minus negative 6, same thing. Two negatives make a positive. Negative 24 plus 6 would be negative 18. So my final answer for the area of the shaded region would be 37x squared plus 3x minus 18.